In 9.2, we're going to discuss geometric series. So let's just go ahead first and start talking about what it means for something to be a series. A series is just where you take the terms of a sequence and you add them. So instead of 1 comma 2 comma 3 comma, here we have 1 plus 2 plus 3 plus 4 plus 5. So the idea is that these things may or may not have a finite value. For the one below, we'd have a half plus a fourth plus a sixth plus an eighth. That would be considered a series as well. So that's the difference between a series and a sequence. A series is telling you to do the sum of the terms. So if we look, the notation for a series could be like from n equals 1 to infinity of a sub n. So a sub n is essentially the terms of the series, or a sub n. We were previously thinking about that as kind of like a sequence, but now we're adding a sequence together. So a sub n by itself would have been the sequence, but by putting this summation notation sign in there, by adding that sign in there, we're essentially saying to add up all the terms. So for instance, this one's not an infinite series. This is what we call a finite series, because we're only going to 6, we're not going to infinity. So this notation is to tell us to do the sum from 1 to 6. So essentially 3 times 2 to the 1 minus 1, plus 3 times 2 to the 2 minus 1, plus 3 times 2 to the 3 minus 1, plus 3 times 2 to the 4 minus 1, plus 3 times 2, and on and on. So we're essentially going out until we get 6 terms. So this first term would be 3 times anything to the 0 power is 1. So this is 3 plus 3 to the first times 2 to the first power is 6. Plus 3 times 2 squared will be 4. This is 12. And hopefully you can see what's happening. We're really just doubling. This next one will be 24. This next one is 48. This next one's 96. And so if we add those terms up, we would get 189. So this notation, this thing here, from n equals 1 to 6, 3 3 times 2, then minus 1, it comes out to be 189. This is called a finite geometric series. A geometric series will be in the form a plus a times x plus a times x squared plus a times x cubed plus a, and so on and so on. And so you can see for this, we're saying a equals 3 and x equals 2. For a geometric series, a is going to be the first term. X is what we're going to call a common ratio. Okay, but in general, a geometric series will have this sort of form to it. So to find the sum of a finite geometric series, which we actually did this one here. That's not always the most convenient thing to do, because what if I asked you to find from the first to the 1,000th term? You wouldn't want to add all those up. But we have a formula. And if you can identify A, and you can identify X, and you can identify N, which is simply the number of terms in your series, you can plug it into this formula. So for our previous example, A was 3, X was 2, and N, the number of terms, would be 6. So I can really quickly find the sum of the first 6 terms. It would be 3 times 1 minus 2 to the 6th power over 1 minus 2. And if you compute that out, again, you would get 189. So you'll get the same answer. But we don't care just about a finite geometric series. We want to explore infinite geometric series. If this was to go on and on forever. For the sum of an infinite geometric series, for absolute value of x less than 1, this is really the only time we can find the sum, if that common ratio is less than 1. For the absolute value of x less than 1, the sum of an infinite geometric series is simply a over 1 minus x. So that's pretty simple to do, but x has to be less than 1. The absolute value, I should say. The absolute value of x has to be less than 1. If the absolute value of x is greater than 1, we actually just stop there and we know the series will diverge if it's indeed an infinite geometric series. So these are pretty easy sums to calculate. I mean, if you look at that, that's a very simple expression. If you can find the first term, a, and you can find the common ratio, x, it's pretty easy to do. So it's very important that we can identify if something's a geometric series or not, because then we can really quickly do this sum formula, a over 1 minus x. And so the idea, a geometric series will have a common ratio x. If you take the next term and divide it by the previous, you should get x every time. You should get that common ratio. So let's look at how we can check for that. Here we've got 3 examples, and we want to determine if they're geometric, and if they're geometric, we're going to find the sum. So what you do is you take the next term, 1/2, and you divide it by the previous one. 1/2 divided by 1, well, that's 1/2. Take the next term, 1/4, and divide it by its previous term, 1/2. Well, 1/4 divided by 1/2, again, you'll get 1/2. If you take 1/8 and divide it by 1/4, you'll again get 1/2. So 1/2 is x. That's the common ratio. So we have a geometric series. The sum will equal a, the first term, over 1 minus the common ratio, 1/2. The sum equals 1 divided by 1/2, which is just 2. Let's look at this next one. 1, 2, 4, 8, and so on. If I take 2 and divide it by 1, that's 2. If I take 4 and divide it by 2, it's 2. And if I take 8 and divide it by 4, again, I'll get 2. So x equals 2. So this is geometric. However, will we be able to find the sum of this geometric series? No, we won't be able to find the sum here because the x value, the absolute value of it's greater than 1. So this series is actually just going to diverge. We cannot find the sum. Alright, let's look at C. Now we've got some negative signs in there, but that really isn't going to matter except when we go to find our total sum. So notice we're switching back and forth between negative and positive. Well, if I take a -2, the next term, and divide it by 6, that's -1/3. If I take 2/3 and divide it by 2, I'll again, it'd be divided by -2. 2/3 divided by -2, I'll get -1/3. If I was to take -2/9 and divide it by 2/3, I'll again get -1/3. So for this, it is geometric because I'm getting this -1/3. X equals -1/3. The first term is a, which would be 6. So I can find the sum of this. The sum will equal 6 over 1 minus -1/3. That's 6 over 4/3. And that's the same thing as 6 times 3 over 4, which would give me 18 over 4. I'm running out of space here, but 18 over 4 would reduce. This actually is a sum of 9 over 2.